Before we get started with today's podcast, I want to say a few quick words about the death of George Floyd and the Black Lives Matter protests that are going throughout our country. I am deeply saddened that African Americans are still facing systemic racism. I hope to be an agent of change, so I've made a donation to the Black Lives Matter movement, and I'll be posting a link in the description below.
Everyone deserves the same opportunities and chances for success. Laws can change, but to continue the momentum, people's mindsets need to change. Personally, I've been learning more about how privilege has affected me in ways that I didn't know, and I encourage everyone to do the same, but to most importantly, listen. Get involved and support in whatever way you can, and for me, that's through donating to George Floyd's family. You can find a link in the description if you'd like to join me in supporting a family that's facing a tragedy right now.
Thank you for taking the time to listen to that message from me and my guest, Blake Pastrana. Blake is a software developer who graduated from James Madison University with a degree in computer science. He now works as a consultant for Accenture. Blake and I sit down to discuss computer science and his experience in the industry. This is also a two-part episode, and in part 2, Blake and I discuss his involvement with Drive Fitness. Enjoy episode 5 of the Drive Fitness podcast. Other than Matthew Jamazos, Blake is one of my first software developers on the podcast. So, Blake, I wanted to ask you, for those who are kind of more into fitness, what is software development? What is computer science? Can we kind of just start from, the basics for a minute?
Yeah. And I think it's important for everyone to kind of have knowledge on that, especially because it's what runs our entire system, the world, right? And so many people don't know kind of at a high level how it works, or like it's this magic type thing. So software development really at its core is just about using technology to create things that make our lives better or enhanced or easier. And it's a very broad sense. Computer science is a very broad term that spans across a bunch of different types of computer-related stuff, whether it's the actual hardware, or if it's making mobile applications, or if it's researching into artificial intelligence, security. Like, there's so many different realms of it. But at a high sense, it's just about taking the hardware of a computer and writing code to being able to translate that into something that a human can digest and interact with.
So when you are writing code, right, you use a language that is not, like a human language. It's something that the computer can understand. And can you kind of explain for those who have never looked at like a computer language what that is or what it feels like? I know it's mostly logic, right? If this statement do this statement, but what is the best way you can kind of explain that to someone who's never seen computer code?
Yeah, and I think the best way to kind of explain it, exactly what you said, logic, right? That is, you're basically giving commands, and that's what the language is about. It's giving commands to the computer in a way that it understands. So you're writing out, step 1, do this, step 2, do this, 3, 4, so on and so forth. So it's a way of being able to communicate commands to the computer. And there are multiple different formats, right? Just like you can give commands to another human in various languages. You can do the same thing with programming languages, yeah.
And I know that computers, they just run off of ones and zeros. So something I don't even fully understand is when I get my computer language that I know is something more the computer can understand, how does that get translated into ones and zeros?
No, that is magic. No, no. But basically there's levels of translation that happens. There's ones and zeros, which is just on or off, and then it kind of goes higher and higher levels. So you have assembly language, compiler language. So basically, you can do the same things when you're writing computer language if you wrote purely in ones and zeros, but people have created these programming languages to help make it easier to write code, because it's a lot easier to look at and understand and write bigger applications if you're not just writing ones and zeros. So basically, it starts out at those ones and zeros. Somebody wrote something that abstracts it a little higher and uses assembly language. Somebody writes a compiler that abstracts it even more and kind of turns it into a human readable format instead of just numbers. So it's easier for people to jump on board and start learning and start creating.
That all makes sense to me. And recently I heard that Google had basically mastered something called quantum supremacy, which essentially they were saying that it used quantum computing, which means, instead of the normal ones and zeros, it could essentially like double that and turn. We were texting about it, but do you understand kind of how that works?
Yeah, and it's something that's really confusing, right? Even for me, I don't even fully understand it. I just kind of grasp the main concept of it. And the main concept of it is just, we're talking about ones and zeros, right? And the idea is just, okay, but what if it was more than just ones and zeros? So basically, the goal of quantum computing is basically doubling the amount of information and stuff that you can write in the same amount that a normal computer would do. So it's no longer 1 and 0. It's now basically you have 4 options to choose from, and it can be any of those 4 options. So it makes it much more powerful and can do things much more quickly because you have more information in one bit instead of just 2 pieces of information.
So I guess every bit could then act as a 1 or a 0, leading to have much more different combinations, right? And it felt like, I don't know, that was announced a couple weeks ago and no one was really paying attention to it. I guess no one really understands at the moment like what implications that could have, right? Do you have any idea? I think that's why no one was making a big deal about it, but do you have any theories on what implications that could have on society?
Yeah, so that is a great point, and it's something I thought about too, because it's something about, you have this technology, but is there a need for it yet? And maybe eventually down the road the need for this will rise, but people are doing really a lot of stuff, their day-to-day stuff, without the need for quantum computing. But there are kind of 2 applications that I see that it turns into. Number one, I think it's going to completely disrupt security in a way. So traditionally, when you're trying to break into a computer, when you're trying to get someone's password, you have to go through a lot of computation to get there. And current standards take a current computer a long time to break that. But once we have quantum computers, which are way more powerful and can do things in a way shorter amount of time, suddenly those algorithms can be cracked in, a day. So to combat that, I see, okay, now we're going to have quantum encryption to be able to balance that out. And if you don't upgrade to that, then any hacker or nefarious person with a quantum computer could potentially break into your system relatively easily because it's not up to date in that sense. And then the final one is just the ability for simulations and the ability for modeling being a lot higher. One thing I like to think about is kind of like the real world. There's a lot of math going on around us at every time, right? There's physics going on, there's gravity, like everything has some force applied to it, and there's some equation going on around you that you can't really see. And I think with a better computer and a processor that can handle all these calculations at once, we'll be able to do better simulations of maybe just modeling, but maybe eventually virtual reality, right? Where you have the ability to make things more lifelike because the computer can actually handle all those calculations around you at the same time because current computers aren't powerful enough to do that. So that's kind of where I see it going from my sense.
Yeah, no, that was a good point about virtual reality. It seems like our phones are getting better every year, right? But we've kind of hit this peak of fitting a computer into a small enough device that we can put in our pocket. And sure, we can make it smaller, but it's pretty comfortable to carry around a phone. But when it comes to virtual reality, right, it seems like we're very much lacking the potential here. We have these either clunky devices or these things that adapt to our phones, and it's not quite, it's exciting. Virtual reality is very exciting, but it's not quite where it could be. And we're all working towards a way to compress that down into a smaller device or like, a pair of glasses or something that can be more seamlessly used. And maybe this quantum computing can really push us to the point where VR, hits this level that we kind of want it to be.
Yeah, no, and that's definitely true. And it's really interesting too when you're talking about virtual reality about kind of where you envision it going, right? Because like you can go to this full-on virtual reality where everything is synthesized around you, or there's augmented reality where it's real life combined with some virtual reality to kind of show you things in combination with what you're actually seeing. And I think there are arguments for both sides. But what do you think? Do you think the future is in virtual reality, like completely virtualized realities, or something somewhere in the middle where it's real life with augmentations?
I think that augmented reality is going to be something that everybody uses in their everyday lives. I think that we're living in this weird period of time where we're staring at screens all the time, and I think this is going to be a little blip in the long-term history of things. I think that working 50 years from now, you're going to be typing on a keyboard, but your screens are going to be more projected in your vision, and you're not going to be as limited, to what you can do on a screen. You're going to be able to kind of jump in and out of web browsing easier and more seamless with augmented reality kind of layered over your eyes in some way, shape, or form. And then I think that virtual reality will be like either special occasion thing, or just a small portion of the population will be very, very into virtual reality. I don't think that it's going to be like a everyday kind of activity, or every person or profession kind of activity. It's going to be not something that everyone's going to go do, but for the people that do it, I think that there's huge implications on learning skills like, how to do a surgery. You could go into VR and learn a lot of skills there that you would have to practice over and over again, in real life. So yeah, I think that there is a lot of potential with VR, but not everyone's going to tap into that the same way that like cell phones are just everyone has those. It's a standard piece of technology. I do think augmented reality is going to kind of layer over top of us in a way where everyone is going to need it to kind of function in the world, to be honest.
Yeah, no, and I think that's a good comparison with cell phones too, because I almost see it as like augmented reality is like the smartphone, whereas virtual reality is like your desktop computer. One's you don't use your desktop computer all the time, but it's for that kind of heavy lifting when you really need to be immersed. So maybe for your work or for other things, but all the rest of the time is just augmented reality.
Yeah. Kind of like video games too, right? Like not everybody plays. A lot of us play video games, but not everybody sits around and wants to play video games for 3-4 hours a day. Those same people, I think, are going to be sitting in VR, right, doing those kind of activities where it's going to be cool, it's going to be fun to mess around with, but it's not going to be a necessary part of kind of getting through society. Let's say I'm a high schooler and I'm about to graduate and I'm considering computer science as a major. Do you have any advice for beginner programmers? Do you have any advice for even deciding if this is the right major for you?
To kind of start out, you should just kind of research online. One of the great things is there's so much content on the internet to start programming. And if there's something that interests you in particular, whether maybe it's game development or if it's mobile app development, web development, just kind of look at the free courses and watch some YouTube tutorials on that. And that'll kind of give you a broad picture of what programming is like. And that won't give you the full scope into computer science because it's so much more. But at the end of the day, I feel like it's such a strong basis for it. It'll kind of give you that idea, because the way to go about thinking about programming is such a unique mindset. And that's why a lot of people will say, everyone should learn how to program just because you can apply it outside, because it's such a logical, it's just problem solving, right? It's like I think if you're enjoying problem solving, you enjoy being given a toolbox and you've been given a problem and you are said to fix it, and you figure out how to fix that problem with the tools at your disposal, that's kind of up your alley, and you should start exploring that. So following those YouTube tutorials and seeing where you kind of lie and what kind of realm you want to go into computer science. And that's kind of how I got started too, in finding the particular lane, right? Like they teach you stuff at college about broad computer science, but to go into those individualized topics, when I started mobile app development, when I guess I was like 17, 18, I was watching tutorials, I was reading things online, I was following content creators, and that's kind of really awesome way to get your start and to figure out if it kind of suits what you're looking for or what interests you.
I taken some courses in college, but I really learned a lot once I had my own idea, or like you said, I picked my own problem and I started trying to solve that problem. I felt like it was much more engaging to kind of go online and find things that helped me kind of fit my problem or fit my interests. You don't just have to be interested in computer science. You could have a totally different problem you're trying to solve. Like for me, it was fitness. And now you're using computer science as a tool, to help you in this other area. And it just automatically engages you, right? And allows you to learn without just going through tutorial videos or just, researching computer science topics. And you just kind of naturally start learning these things ahead of time. What about a beginner language? Do you have any suggestions on maybe what's the easiest language to start off with when you're just learning the basics of computer science?
When you're looking for a beginning language, you kind of want to look for something that's not too strict or too daunting, but also still follows some of the best guidelines and principles. So that way you're really getting the kind of the full picture of things even when starting out. I think Python's a really good place to start because it's really easy to get up and running and to start coding there. But I think one of the best ways to get started out when you're learning, I would take a look into web development. I would try to create a website using JavaScript, whether it's a certain library such as Angular or React, because that will give you kind of the full scope of how things are structured, even in big enterprise companies. And it's a little more tangible, right? Because you get to see the feedback. And that's one of the cool things we were talking earlier about, trying to solve your own problem, how more engaging that is, right? Like you start out with an idea and you take your first step. And then when it's time to move on to the next thing, you're like, okay, I want profile pictures in this. So I'm Googling, how do I implement profile pictures in my website? And it kind of just builds from there. So I really think a website is a great place to start because it's something that you can feel and you get immediate feedback on. Whereas if you're just starting with a language by itself without any visual elements, it can just seem really disconnected from you and it's not as concrete in a way.
Mm-hmm. So maybe if you're more into like artistic stuff and like designing the look of a website, you might want to start more with website design, which is usually HTML language to set up the elements on the website, and then a language called CSS, right, that kind of formats it, styles it, puts colors into it, size, all of that. So if you're more into the look, if you're more of a visual learner of how to create the look and feel for how a website would look, start there. But then, as you were saying, Python is maybe someone who's more of like a mathematician, more into algorithms, more into like solving problems like on the calculation end, right? So maybe Python's is a good language to start over there if that's kind of more of your interest.
Yeah, I think it really depends on the style of person you are, right? Like I am one that really likes that visual feedback and I really enjoy making and creating things. And a website feels like you're, architecting or creating or drawing. And then the actual code behind it, if you're doing Python or things of that nature, is more of that mathematical kind of. So if you're a data person, if you're a numbers person, if you're a really logical person, then that I would say Python's a great start for you. Yeah.
Okay. So you went through JMU's computer science program. I know they started you off with Java. What was your impression of their program? What was some of your biggest takeaways? And other than Java, what kind of other languages did you hone in on?
We started out with Java, and we started out with a intro to programming fundamentals, which was based in Java. And that was kind of the prereq class to continue forward in the computer science major. And that one was a really interesting setup because it's kind of like feast or famine, because if you don't do well in that one, you can't continue on. And there's a reason for that, because if you don't learn that stuff, then you're going to have a very difficult time going further, because that kind of is the foundation and it kind of serves as your point of reference moving deeper and deeper. So it's really important in that sense, but it's so new and so overwhelming to people that it's more about finding people that are dedicated to figuring this out and learning about it, right? Like I feel like anybody can learn how to code. It's just whether or not people want to put in the time or effort. So I felt like that was a really great class to kind of set the standard while also giving you some real world experience, even if it was extremely hard. And from there, we kind of branched out further into data structures, algorithms. I touched on Python a bit. I've touched on SQL, and then it kind of transitions into C, which is really a low-level language. It's a little more complicated than Java in a sense. You can do more. You can interact more directly with the hardware with it, and that's kind of the upper-level, senior-level CS classes. And that was really, really hard stuff, but it really gives you the full scope of kind of computer science, because it's combining your point of reference there at the very beginning, but now you're really diving deep into the actual hardware and how computers operate. And I think one of the hardest classes for me actually was operating systems. So, everyone uses Mac OS or Windows, right? But starting to try to code your own, that's when things get a little crazy, right? Like how does a computer operate? How does a OS work like that? How can it run multiple tabs or multiple programs at once? These are all really complicated problems, and you start kind of taking it piece by piece. But overall, I think the program was really awesome, and I thought that it gave me a good broad sense of kind of each kind of sect of computer science, and then from there, it's up to the individual to choose. All right, which one did I enjoy the most? Which one do I want to continue down the path of learning on?
So earlier we were talking about ones and zeros, right? And when you talk about a low-level programming language like C, you're saying that that language is closer to speaking in ones and zeros language. Not necessarily ones and zeros, but it's closer down towards the actual hardware, the way the computer understands things, than just a minute ago we were talking about website design. That's almost as far away as you can get, right, from that computer language. And I think this is true from my understanding, but the syntax, right? So the rules that come along with a language, the further away you get from that computer language, like the computer understanding, the easier they are, right? They're not as rigorous. I know I use JavaScript a lot, which is for website design, and you can kind of get away with a lot, right? As long as the computer can kind of figure out what you want, your code won't break, it won't refuse to run. When you get down to like a language like C, right, does that come with a much more rigorous set of rules? It essentially won't compile or won't run unless you type it a specific way. Is that correct to say?
Well, yes, in a sense, but I think as far as writability goes, it's not that different from kind of a mid tier. But you're absolutely right. Where when you're taking a look at those high level like HTML and CSS, which CSS in and of itself is not really traditionally speaking a language, because it's a style sheet, right? But then when you're talking about a low level programming language, it's more about, in Java you set a variable, right, and it kind of handles that for you, and a variable is just the storing something in memory to use later. And you don't worry about how that's stored. The computer worries about that. It abstracts that away because it's easier to read. It's easier to write programs faster because you don't have to worry about that. But in C, you can tell it where in memory you want it to be stored. So you can actually say, yeah, store it in this particular spot in memory. And the problem with that is it's really easy to mess up. So it not necessarily won't compile, but it's really easy to crash the system because you're trying to access something that doesn't exist, or you're getting into issues where you're running out of memory space. There's a lot of problems that come with that, but there's also a lot of power that comes with that too. You can do a lot more.
Not only, maybe the syntax does get a little harder, but you're saying more importantly than the syntax, the rules with it is you're gonna have to be much more specific to how you're talking to it. So when I deal with like an upper level code, I can just say, hey, this mic equals M, right? But down there on a level like C, you might have to say, hey, this mic equals M on the table, right? You got to tell it where it's going to be placed as well. And then when you want to grab the mic, you got to tell it, hey, give me that mic from the table. You can't just continuously grab this mic, and let the computer understand where it is, right?
Right.
Okay.
And what's interesting too is at the end of the day, all the programming languages kind of work like that, right? But it's the level of abstraction, right? So so at the end of the day, a higher level program works the exact same way, but you don't have to worry about it. You don't have to deal with that. So it's kind of interesting that how high level of a view you want or want to deal with.
That's really interesting because I guess as we were talking about how it evolved, from ones and zeros all the way to something like a website language that a lot of the abstraction is already done for you. Do you think that over time it's still going to be important for like everyone to learn how to code? I feel like eventually we're going to abstract coding all the way to the point where it's English, where I can type in, hey, I want a fitness app that does this, and this, and the computer will compile it and like solve it all for me, right? I feel like eventually, I don't know how soon, we're going to reach that point where the computer understands English, and that is like the highest level of abstraction, and all the other problems underneath that would already be figured out. Is that fair to say that is eventually where it's heading?
I think so. And especially now in the industry, there's a lot of buzz around, no code or low code environments, which means drag and drop kind of sort of UIs, things that make it easier to create things. And I think that any kind of tool, even outside of just programming, kind of strives for making it easier to do and to create. So I think eventually it will get to that point, but I don't think it necessarily will go away. I just think that the type of work will shift then to creating the things that enable that, right? So you won't have as many programmers going across, all these different, making a website, making mobile applications in these specific languages, but you have a lot of programmers focused on making a program that helps and making those software pieces a lot easier to create.
Okay. So yes, we're moving towards a place where maybe, I'm not going to put a time frame on it, but at some point you might be able to type in English into the computer and it'll know what to do or make. But you're saying that's not going to create a world where there's no job for programming in general. There's always going to be another project, another idea, or another way of simplifying things that would cause a need for programmers, to help things move in this direction where it's simplified for the rest of the world.
Right. And I think on the path to get there, I think the point where it gets to that, where there's not a need for programmers across different languages and the kind of what we're used to right now, it's going to be a long road. And it's going to continuously get better, but until it gets to a really, really good spot, people are going to want customized solutions, because if you try to do a one size fits all thing, you're going to realize that some things don't quite suit your needs. So take it like for a mobile app and fitness, for example, a lot of people will probably use a different food tracking, calorie tracking app versus the app they use to track their workouts or to record their data, right? Because maybe there is an app that does both, but maybe it doesn't do both extremely well or to what suits their needs. So until the point that it, like far out in the future, it might be able to do that. But until we get to that road, there's always going to be that demand for those customizations.
Yeah. I just bring it up because I know that there's this focus on like learn to code because of like artificial intelligence. And, the more you look into it though, and the more you really think about it, there's actually a lot of like developer jobs that could be automatically autonomized by artificial intelligence, whereas like a job like a mechanic who comes and fix your AC unit, it might be a lot longer before we can build a robot that comes to your house that fixes your AC unit. It might be a lot sooner that we could build just a AI agent that can actually type up software into a computer. So I'm not saying that don't learn to code, right? Obviously, like we were saying, it's going to be a long time. There's still going to be a need for developers. I just found it kind of interesting that that might not actually be the safest job ever, right? And that we're sort of moving towards a point where it's abstracting further away from the actual code that's getting written. Like we're no longer writing with ones and zeros, and maybe we'll no longer need specifically like code to create apps. I don't know.
Yeah, no, and that's one thing that it took me a degree to realize is that when we think of traditional programming, you say, web developer, mobile developer, game developer, things of that nature, that is really important, and there's a lot of different depth you can go into that. But that just kind of scrapes the surface of computer science, and there's so much more, right? And quite honestly, you don't need a degree to be a game developer or web developer, things of that nature. It certainly helps and gives you a lot more context, and it allows you to branch out a lot easier. And there's a lot of different benefits that go on and on about having a degree with that. But at the end of the day, it's not really the, like you said, safest job out there in the computer science field. So it definitely is kind of up for grabs in that sense when it comes to AI. As if you're looking at the kind of computer science world, that might be one of the first things in the computer science field that does get automated or severely impacted in some way.
We might talk about this a little bit more later, but you've moved into your career in more of like a managerial position where you're telling other developers, how to do things and how to code something, right? But as I was saying, you've actually abstracted that to the point where you're using mostly English, right, to manage these people. you might not be writing code in your day-to-day life as much as you used to be. So I think in order to get to a point where you're managing people, or maybe in the future managing AI agents to make an app, right? Even if you don't write code, you still might have to take that journey through learning how to code so that you can get to a point where you're effectively using English in a way that can help make an app. I think it's definitely worth anyone who's interested time to learn how to code. And I think that it's going to be a very valuable knowledge whether or not you're writing code every day in the future to understand how these processes work. I wouldn't want to just skip out on understanding how an app is created, especially if I want to go into a tech industry. If that makes sense.
Yeah, and I really think that that is the inevitable future. But I think at least in our age group's timeline, if it happens, it'll be at the tail end. So I feel like it's definitely important now, and it's important for people to learn that now and to contribute to the growth of technology in general, in a sense, right? Like help push it forward to a point where things are better, and things are more efficient, and kind of propel technology and the human race forward by participating and helping.
Yeah. Maybe learn to code more so that your grandkids don't have to or something. But you think that there's still going to be a large need in the next coming decades to help get it to anywhere near the point I was talking about, where things are just more automated. Okay. Still kind of sticking with your time at college, I know that you started working on several side projects at that time. I think maybe this is kind of a time period that piqued your interest in entrepreneurship. Can we talk about some of your early projects that you built in college?
I remember freshman year of college, I was starting my courses in computer science. I hadn't really done any programming prior to that, and I was taking that intro to programming. And I had always loved the idea of mobile applications, and I was really interested in it. And I wanted to start learning about that because there's not really courses for that in college. There might be one or two offshoots that you can find in some colleges, but for most part, right, you're not going to find a specialized degree in that. So I knew that I really wanted to start learning about that. Knew that I wanted to make an application. I knew that I needed to be somewhat simple, right, because this is my first project in mobile application development that I'm journeying down. So I was trying to create an idea that would be useful to me, useful to those around me, which at the time were people in college with me, that was also somewhat simple. So the idea of doing something that I was doing manually when it came time for finals was to figure out what score I needed to make on a final to reach a certain final grade. So you basically, you put in your current grade, you put in how much your final is worth, and then it's going to tell you what you need to make on your final to get X amount of grades. So like, let's say I want to make an A, I'm at a B. So I put in my current grade, and then I put in the final's worth 15%. That's great. You need to make 94 on your final to get an A. And it's like, oh man, I actually don't know if I can do that. But I worked with one of the guys that lived in our dorm room floor, and he was doing the graphical design, the assets for it, and we created it and put it out there. And because it was just like a one-page app, it had one algorithm and it was just one button, we got it out, pretty quickly. But it was such an important step to actually just get it out there, right? Like at that point, it didn't really matter what it was. It was just the fact that, starting a journey and then pushing it out to the world. And that's kind of what lit the fire for the future me, right? To continue down this path of entrepreneurship, creating your own personal ideas, and then continuing down with mobile applications.
It seemed like, I took some computer science classes that could have easily been a project for one of these classes. It seemed like what took this idea a step further is like, okay, let's actually give it a user interface. Let's pick the colors out, the icons and things like that, and put it into a mobile app and put it on the store, right? That was kind of a big leap from anything you'd ever done in class, right?
Right, yeah.
All right, so one of the last things I wanted to talk to you about regarding computer science was your career. Based on what you've told me, it seems like you started off, software development position, and in the past year you've moved up to some sort of management type position. Can you kind of detail that transition?
Yeah, so I started out at my current company by being a web developer. So
Wait, what is your current company again?
Accenture.
Okay.
So I work developing software and consulting to federal clients.
Okay.
I started out doing web development, so traditional, just making websites for the clients, basically. I was still working on my side project, which is mobile application development, and part of during that time was also working on Drive, right? And I really wanted that to be kind of my full career because that's what I was really, really passionate about. So I kept doing these side projects, and then there was an opportunity at work to work on mobile development there. And I said, I want to do that because that's what I do in my free time. This is what I love to do. I'm very passionate about it. And I was able to do that transition because I was able to say, hey, look, I'm not just making this up. Like, look at some of my past work. And I transitioned over to the mobile development team. And there I just started taking on more and more responsibility. So I think the big thing that shaped my career was just there was a lot of freedom in a sense, and I was able to kind of shape it how I wanted. And I was kind of able to take charge and to really have a vision and commit to it and get people interested and behind it and lead the team there. And really the switch to what feels like more like a managerial position is from the communication aspect. And that's one of the important pieces if you're interested in tech, but you're also interested in becoming a manager type worker, then you need to be able to bridge the gap between technicalities and the business side or the clients or even if it's not related to the clients, be able to lead a team of developers, right? So you need to have strong language skills and strong technical skills. That's kind of why this interested me so much because I had both and I loved both. So I just started using that more and more and started really thinking about ways to push the envelope from a development standpoint and get the clients excited about it and get their support, which in turn gets support from my company, and then it continues to grow from there.
Okay. So working in a big consulting company like Accenture, you basically found it pretty easy, right, to kind of guide your own career. Like, obviously, you have to do what the client wants. You have to work at projects the company needs. But with it being such a big company, you were able to navigate these projects in a certain way that allowed you to move into the right kind of skills you wanted to learn. When you moved into mobile, didn't they use Ionic as well? Is that kind of what helped you make that transition?
Yeah, so one of the key mobile applications that my client had was an Ionic app, incidentally enough, which I had just got done working on it with you on Drive, and so I was familiar with it. And they had they have like 8 or 9 different mobile applications, and 2 or 3 of them are written in Ionic, and the rest are in native. So having that skill set definitely helped because I was able, I released 2 apps back in the day with native, and then I was working with Ionic, so I kind of had a little bit of both.
Best of both worlds. Nice. Okay, and at this point, you said you're in a semi-managerial position, right? What does it take to kind of oversee a team of coders? I know you said great communication. What other aspects of your job, are involved with kind of overseeing coders and communicating what's going on back and forth between them and the client? What are some struggles that you've had maybe having a coding background instead of more of a business focused background?
Yeah, so I think one of the key things is to kind of separate yourself, being able to envision yourself in the client's position and figuring out what their goals are and try to understand. And I know that you, like me, we're very much like people person in that regard. We like interacting with people. We like talking to people about things. We like helping people or showing off some of our stuff to other people, right? And I took that kind of approach, right, and trying to figure out really what their goal is and how they want to implement it. And I think one of the biggest challenges for me from a personal standpoint is kind of taking a step back on the actual development, right? It's like being responsible for something that you don't necessarily have your hands in to the fullest anymore. So that's kind of one of the difficult things is kind of separating yourself from that and then trying to kind of do both things at once and not doing either thing completely fully. But that's where having a great team really comes into play and choosing the right people.
Okay. So once you understand kind of what the client wants, their needs, their goals, all of that, when you turn back around to your development team, right? How much are you kind of deciding what technologies to use, what frameworks, processes, all of that, and how much are you delegating that to your team? And then what kind of maybe softwares do you use to manage the team and processes do you? I mean, I'm assuming you use an agile process, right, to put out sprints and things like that.
We're a team, so I'm not necessarily making those decisions on my own. I think that's the biggest thing too, as a technical manager. You're not going to be the one, like I said, with your hands in the code all the time. You're not necessarily going to be the one that's developing it all out. So you can make a decision that maybe your team of developers really hates. So it needs to be a group decision. And so really the position is bringing up the options and kind of using that technical background to make those decisions, like I said earlier, about risks, things of that nature, and then hashing it out with your team to make those decisions. And I think that's one aspect of it. But for more the day to day, because maybe you guys got that all situated already, and you're talking about more of the day to day stuff. Mm-hmm. That's kind of using the agile process, right? Figuring out what the client wants, breaking it down into smaller chunks, and then using the agile process to divvy up that work into 2 weeks time, and figuring out what can we get done in 2 weeks, and work on that for 2 weeks, and then we take a look at the rest of the stuff that's still to do, and then pull out another 2 week chunk, and so that's really helpful.
Do you use Jira, or what kind of software do you use to schedule out these sprints into 2 week periods?
Yeah, so we use Jira for managing the agile development process. So tracking our user stories, which user stories are just basically writing out features of the app that you want to implement. Or maybe it's not even features, maybe it's where you track bugs, things of that nature. Just basically documenting things that need to happen to the code. So we use Jira. We use Confluence, which is a Jira kind of side player, and it allows you to document things. So it's a documentation service, so you can write up your technical documentation that helps onboard new people or things of that nature, and that's really helped. But I think the biggest tool that has helped out is Jenkins, and it doesn't have to be Jenkins, but Jenkins is a CI/CD pipeline tool. And you want me to go a little more in depth?
Yeah. Explain that.
Yeah. So that is CI/CD stands for continuous integration and continuous deployment. So what that means basically is that you're continuously developing and you're continuously deploying code. So if you think about a website, for example, they can update a website whenever they want, and next time you visit it, right, it's updated. And the idea of this continuous integration and continuous deployment is that this happens very, very frequently. Back in the past, there'd be a long gaps before you get, an update that contains a lot of things. But this idea is you're constantly getting an influx of these things as they get finished. So it's not like you're waiting.
So as every feature gets built, there's some sort of check, right, that makes sure it's working well, it works with the rest of the app well, and then that feature gets pushed into the website or the mobile application almost immediately without waiting for like a group of features to all be ready and all pushes like one big update. It's just kind of continuously adding these new features and bug fixes as they are ready.
Exactly.
Wow.
And it's kind of interesting you bring that up with mobile too, because that is actually one of the hard cases to crack, right? Because it's very easy with a website, because when you visit it, you get what's there, right? But when it's a mobile device, it works kind of similar to like a desktop application where they have to update their actual application on their phone for it to go through. So that is less continuous necessarily than the web piece. So you can still utilize that, but then you still kind of chunk it up because of that process that's in place, right? Because you got to get Apple to approve it and stuff, and you don't want to send that every single day.
Well, I've noticed more and more that these updates just seem to come on the fly without me actually going in. I remember, when iPhones first were becoming popular, you would have to go in and click update on every single app, or maybe you could even decide, I don't like the new update, I remember Snapchat, there was a huge debacle over an update that people didn't like. But it seems like, maybe I haven't even been paying close attention to it, my phone apps will just update without even telling me. Right? Is that the new way of doing things?
It's pretty wild, right? Like you open your app and it's different, but you didn't download an update, And if you check, some people might have like automatic updates on, but this is not happening because of that. What's happening is they're finding ways to be able to update and do this continuous deployment with a mobile application. And part of that is by making the actual UI and pieces of the app dynamic, in the sense that, if you want to change something around, you don't have to deploy a new version of the application out. You just go into your database and you say, oh, I want this header to be up here now, or I want the profile picture to be this big.
Okay.
And it renders dynamically, and it's really powerful and really, really interesting concept.
Wow. Yeah, that's a lot of information to store in your backend, but I guess it does now give you more and more capabilities to creating changes without deploying a new version or anything. That's really interesting. Okay. Well, is there anything else you want to add about kind of your career advice towards maybe developers that are transitioning between college and their career, as far as finding jobs, getting a footing in, and just kind of how to be successful as a professional software developer?
Yeah, so the first thing, and this kind of goes outside the realm of computer science, but I think it's extremely important with computer science, is to always be learning. Always be working on something, to always just ingest that information, especially with computer science, because it's so dynamic. Things change so quickly that you need to be up to date, and really just kind of keep working on your side projects. One of the things that led me to get my first job out of college, and I attribute it a lot, is those 2 mobile applications that I put out. It didn't really matter what they were, but the fact that it showed that I had initiative, that I was able to start something without any kind of guidance and see it through. And it tells a lot about a person. And when I'm doing interviews, that's the kind of thing I'm looking for too, because you can tell a lot by a developer by things they do outside of their work.
Yeah, for sure. This side project has definitely kept me continuously learning throughout my end of my college experience and early career, where there's certain times at my job I felt like it's become stagnant, and I'm glad that I've continuously kept, pushing myself. And I think, right, like you said, outside of the computer science field, it should go for anyone, that graduating from college is not the end of the road. It's more of like the beginning of your adult education, and that if you do want to become successful, like, you're not going to see payoffs right away, right? But if you continue to grow and educate yourself, many more opportunities are going to open up and arise that you didn't even see coming.
And I think the other thing that I would say is to take ownership of your work. And that's really what led me to the position I am today in my career. And be proud of your work. I know that not everybody's working in their dream job, right? But at the end of the day, this is something that you're spending, 40 hours a week on, maybe even more. And this is kind of like the legacy you're leaving. And even if it's not your passion or not necessarily what you would do, that's still somehow a representation of you. And take ownership and pride in that, and really pour yourself into that. Don't accept subpar work. Just really, really dig into it and really say, look at this. Look at how awesome this is. And really, that's really the key way to separate yourself, is caring about that and really putting in the love and effort. And I think that's really important to creating a beautiful product at the end of the day.
No, I couldn't have said it better myself. I agree completely. This has been part 1 of 2 of my interview with Blake Pastrana. Tune in soon to hear part 2, where Blake and I discuss his involvement with Drive Fitness.